Question about introspection. I'm actually not a Python user. A good friend gave me a demo, and what he was most jazzed about was when they got their implementation was written in Python, and when they got that bug report from the field, there was this beautiful stack trace.
Right.
Variables, values, the whole works. Now, is that lost in Iron Python, or do they preserve that?
You know, I'm not sure. I imagine that there are two variants of Iron Python. So I said in the slide, it's 40% faster or it's 80% faster. It's 80% faster if you don't create Python stack frames and allocate them in the CLR. So I assume in that case you probably would lose quite a bit of it. I assume in the 40% faster case that they still exist because the existence of a frame object that you can introspect on should be able to provide those trace backs.
I mean, this is actually something that more VMs ought to do better. It could. It just gets left off.
So I'll say one thing to that. The CLR has a full reflection API, so you can basically get the value of every variable in the stack.
Yeah, I think you can do quite a lot of introspection even if you turn off. It's really some very advanced use of introspection, which is difficult to do.
So I was curious about, in terms of the question, I was curious about whether or not the CLR provided, and maybe you don't have familiarity with this, but provided the right semantics, basically, that whether there was a mismatch between, you know, I don't know if you have closures and things like that, in terms of how they fit with the CLR.
Yeah, since I didn't do the work, it's hard for me to speak to it directly, but I wanted to sort of include some information about that. My impression, suggesting that the implementation was very much like Jython, is that that there's some mismatches. So Python has generators, in the style of Python generators or cruise iterators, and I imagine that those aren't, natural to implement in those environments. And on the other hand, I know that Jim Hugan and I talked to him about, what was the genesis of this project. There's sort of this buzz that the CLR was bad for dynamic languages. And his reaction was, well, that's really strange. As a second mover after a JVM, they should have been able to do that right. But since they didn't, I'm going to try to implement Python and show all the places where it didn't work. And his surprise was that it was actually easier to implement than Jython and faster than CPython. So he's working for Microsoft now.
One issue is that Python provides an ID method on object that returns an integer that is unique, and the CLR can provide that.
What was it?
You need a method that provides an ID, an integer ID of an object, and that ID is unique.
Oh, unique ID. Okay.
Yeah, so that for example,
it needs to be stable, so
right.
you can't use the address of the object if you have a.
There was some games that he had to play. I remember when I talked to him after his talk on method dispatch, because Python allows you to either delete a method from a class or change the implementation of a method, which the CLR, it doesn't let you do. So he had to put in some proxy for the method calling to allow you to go ahead and do that.
But I think it uses delegates to represent methods, and you can store as many delegates as you want in an object, so you can also remove them. So it doesn't map Python methods to CLR methods.
One clarification, one question. Clarification, I may have missed this earlier, so I'm sorry. You said 230,000 lines of source code.
Yeah, I think it's 320,000 lines.
320. Okay, it's a transcript.
Yeah.
From the error.
Yeah.
Right. Now, is that all C code, or is that C plus Python library?
That's all the C code. The standard Python library is another 500,000 lines of Python code.
Okay. What accounts for such a large body of code then?
Let's see. If I try to break it down, I think about 20K is sort of the runtime proper. There's about 50K, 20K in the interpreter proper, and 50K in sort of the runtime. So the implementations of all the built-in types. The largest of which are, probably Unicode is particularly expensive to support, and the big numbers and the support for relatively efficient long integer operations.
So the interpreter itself really is only 20,000 lines, which is what I would expect for an interpreter.
That's right. So the front end
and the rest is just corrupt the
right.
libraries that you rather not write in C.
Yeah, I mean the basic object runtime is written in C for performance, and
the C word. So the real question that I had was, could you give us the 2 or maybe 3 worst experiences you had because you wrote this in C? So what is it in the C language that you dislike the most whilst developing these 320,000 words of code?
Yeah, that's a good question. I don't know. I mean, I suppose in part it's a reaction to a new feature development that goes on in C Python versus Jython. So the C Python development is more expensive. So you implement a new front end. Just implementing a new front end for Python. A project that took many months, and the Java people sort of saw the work that was done. It didn't have to do design work up front, but sort of replicated it for Jython in 3 weeks or something. So it's sort of just the day-to-day effort of C programming and catching.
Anything you can think of off the top of your head that could be changed in C that would make your life a lot easier?
Real strings?
Yeah. I mean, memory management is obviously one of the more complicated things. The reference counting is relatively straight to get forward. One nice thing about CPython is that the garbage collector is 1,200 lines of code plus the reference counting. The reference counting is tedious to get right, but it's easy to debug. So we have very few sort of memory management or garbage collector corruption errors, and always easy to debug. But the fact that you've got to do that all the time is tedious. So if there were some better way to do the memory management that was still amenable to people writing C code and linking it into the interpreter, that would be great.
So if you had, for example, first-class macros, would that help? To transparency wrap all of the reference counting stuff around?
I don't know. Sort of alien to my notion of C programming. So
I'm afraid we'll have to defer any further questions to later. Do we have any question we want to add to topics?
So maybe I will answer your question in my talk tomorrow, actually.
Oh, great.
My talk is about writing Python in Python because instead of C, so I will motivate why I prefer to write in Python instead of C.
I look forward to that.
Do you want to add one of your questions to?
I wanted to know sort of why Jython development was stalled, whether it was there's some fundamental problems with it, or whether it was just people not having time to work on it.
It's simply people not having time to work on it. The person who's been doing most of the development lately, I think, sort of has the sketch of the next things to do to catch up with the current definition of the language and doesn't have time to work on it. I think in part, while it would be really attractive to me if I were a Java programmer to have this other language that would be more expressive to layer on top of it. People who use Jython often end up switching over to regular Python. I guess it's not as compelling a case as I would imagine for Java users, or people aren't as committed to Java, so it's hard to say.
I mean, I could put cost of developing in C on here, but I think it's sort of more a general software engineering question. It's probably not really specific to virtual.
Right, but Michael, there was discussion about what's the right implementation language to implement something like Python. And if that implementation language has its own virtual environment, how do they interact with the Python virtual?
Okay, so this is Michael Heinke. You of course all know him, and he's going to talk about myths of dynamic optimization.
Thanks, and I have to keep this down to 30 minutes because I set the wrong tape speed, so the tape's going to run out. Real incentive to get to lunch on time. So the point of this talk was going to be debunking dynamic optimization myths, things that people may believe are true, but